delivering security software in the cloud. Have expertise in email and web security, and specifically in cloud gateways. I also have expertise in the software development lifecycle and in scaled agile and DevOps. So I started with a bachelor's and a master's in computer engineering way back, and then my first job was working as a developer. So I definitely know what you're going through. And I have worked as a developer, then I worked as an architect, and then as a director and senior director for large company Symantec. And I was managing a large team of developers across the world in India and the UK and California and Toronto. So I'm Egyptian by origin, but I've lived in Canada most of my life. So I've learned to love the great outdoors and our winter in Canada. So a little bit about me. So why are we talking about application security? So just as Abdullah said, it's hard to ignore the headlines and all of the news about security and the breaches that are happening. Many of the biggest companies in the world are struggling to secure their services. So it's a very, very important issue. And it's very important for developers to be aware of how to protect applications, web applications, mobile applications from these types of attacks. So there's a chart that I love looking at, which is called the world's biggest data breach hacks. And this really shows the growth of data breaches. And I've got the link at the bottom of the slide there. If you go to this as an interactive graphic, you can click on the bubble and it actually tells you a little bit about that breach. And it's a really great learning tool because it lets you find out, okay, what was at the root of this breach? Was it, social engineering? Was it a phishing attack? Was it some kind of vulnerability, right? Often or not, there is some kind of vulnerability at the root of each of these attacks. And so again, it just highlights the fact that it's so important. And attackers are more and more now are motivated by financial rewards. So a lot of attacks now are using security vulnerabilities, or they're using social engineering to attack in order to extract value from the data that they exfiltrate. So for example, passwords, credentials, or if they're taking sensitive data, they can sell it on the dark web and make a lot of money from that. So it's that's one of the top attacker motivations, and that's why it's so important to understand why we need to secure these systems. Also, reputation, right? There's a reputation in the community for hackers that they want to be able to say, I did this big, I did the Twitter breach or the Facebook breach, for example. Also, hacktivism is becoming a big issue. The one other thing I didn't put on here, state-sponsored too. There's certain state-sponsored attacks that are causing big damage as well. And so that's, as part of kind of cyber warfare now, it's a very prevalent issue. So that kind of gives you an idea of what, some of the top attacker motivations, but also to note that sometimes it's just a user who happens to find a vulnerability or a flaw in your system and allows them to get some free burgers. So it can be, it could be something as big as, a state-sponsored attack, or something as simple as a user exploiting something to allow them to gain an advantage in your system and get some free stuff. So, in this case, this story is about a user who found a little flaw in the McDonald's, the McDonald's order kiosk, and found a way to actually get free burgers if they follow a certain path through it. So another thing that's important to know about is the software vulnerabilities. So companies who develop software or even hardware appliances or apps, etc., they have to keep on top of their security, and they have to be looking for vulnerabilities, and they publish their vulnerabilities when they find them. Sometimes external parties will look for vulnerabilities in software, and they will also contact that software company, tell them about the vulnerability, and then the vulnerability gets published. And so there's a database of vulnerabilities called the Common Vulnerabilities and Exposures, CVE. It's a CVE database that publishes all the known vulnerabilities from software companies that that publish those vulnerabilities willingly to the public. And so over time, you can see there's been massive shifts in increases in vulnerabilities. So there was a large increase around 2006, 2007, in that time frame. And there's another big shift you can see again in 2017. So, you know, more and more vulnerabilities as companies ramp up their effort to secure their software, more vulnerabilities get discovered. And then in discovering those vulnerabilities, it becomes a rush to patch the vulnerability. So one of the things, one of the comments here that I pulled from Robert Secord from CERT, which is a secure coding standards body, is that reacting to vulnerabilities is not working. There's so many vulnerabilities that they're reacting to that they need to eliminate those vulnerabilities resulting from the coding errors before it's deployed. So it's much better to secure the code before it gets deployed to production than to discover the vulnerability when the code's already in production and having to go and rush and patch that code, which is vulnerable in production. So that's driven a big need for secure coding standards, for secure coding training, etc. And so a lot of the knowledge base of secure coding comes from the fact that we're trying to secure the code before it goes to production. So what is secure coding? So secure coding really is the practice of developing software in a way that guards against accidental introduction of vulnerabilities. It's a really important mindset, and I think of it as, you know, you have to develop this this superpower to recognize vulnerabilities in your code and be able to understand what could go wrong. Think about your code as what could go wrong in this code? What could an attacker exploit? And so you have to be thinking of that all the time as you're developing your code throughout the life cycle. So from the point of design, from the point of implementation, and then also in the testing. You want to test for those vulnerabilities as well. So, and a little side note I thought of, I mean, secure coding is quite a broad term, and it typically refers to application security. So application meaning your web server, what runs on your web server and your database, right, which is your forward-facing, or it might be an embedded piece of software, or it could be a mobile app. So that's typically the application. And it typically, traditionally didn't encompass the area of network security, which has to do with securing your network, your firewalls, your VLANs, your web application firewalls. So all of these components that go to secure the network, that wasn't part of application security. But with the advent of DevOps, where everything now is code, infrastructure is now code, now secure coding has to encompass the code in the infrastructure as well. So it does include secure coding of the cloud, right? So there's something called cloud security. There's something called container security, and there's application security. So I'm going to mostly talk about application security, but I do want you to be aware that now with developers having to know more and more about infrastructure as code, the scope actually of code security increases to that level. But traditionally, like I said, the application security is what we're going to focus on. And so I'm going to talk about the attack surface. So when you're coding, you're developing software, you often are focused on the code you write, right? The application you're writing. But the attack surface for an attacker isn't just the application you write. There's more, right? There's the libraries, there's the frameworks that you're using. So if you're using a library that has a vulnerability, that becomes part of the attack surface for an attacker to exploit your application. So it's very important to be aware of what vulnerabilities are in your libraries and frameworks. And that's what I was talking about, the CVE, you know, those companies will publish those vulnerabilities often. And so you have to be on the mailing list, or you have to be keeping track of what vulnerabilities are in the software that you're using. Also, the communication path in and out of the libraries, in and out of the code, you have to be aware of how are you communicating that could also get exploited. The code that protects the paths as well. So you have you have code that's going to secure your communication path using something like an SSL or TLS. You have to be aware of the code that you're using to do that as well as part of your attack surface, and the data used in the application. So data is a very key asset in an application, and that's part of the attack surface that you want to protect. And then the code to protect the data. And finally, as I mentioned, the infrastructure, all the infrastructure that it runs on, whether you're in a cloud service or whether you're running VMs locally, all of that is part of the attack surface. So now we're not alone in this effort. So I want to introduce an organization called OWASP. So OWASP is the Open Web Application Security Project. And so it's a volunteer organization of people dedicated to spreading the word about secure coding and application security. And the OWASP website at owasp.org is one of the largest collections of application security knowledge that's been compiled and is freely available on the web. And there's many, many OWASP projects. There's 194 as of now that are free and open source that you can download, which will help you learn about security and also help you improve the security posture of your software. So as I mentioned, there's things like container security. There's projects that let you simulate a vulnerable application and then try to exploit the vulnerabilities. So you can use those tools to test your own software. So a great place to start with OWASP is the Quick Developers Guide. And these are all links. I'll share the slide deck. And so the Quick Developers Guide gives you a way to walk through where should I start? There's so much to learn about security, but there's a good kind of knowledge path to start with the Quick Developers Guide. And there's also a secure coding practice quick reference guide. So I'm going to show you, this is the developers quick start, just the first 2 steps on that quick start. It has, I think, something like 5 steps or 6 steps. So it says, if I'm new to application security, where should I start? So it says, watch the AppSec tutorial series. So I put a link here to those series. It's a series of YouTube videos, which is really helpful to just give you a foundation in application security and talks about some of the top flaws. Also, the OWASP has a project called the OWASP Top 10, and this is the very well-known standard across the industry. That is the top 10 vulnerabilities that are, and I will talk about those in the rest of this presentation. That's a great place to start, and it's something every developer should know, whether you're doing web applications or mobile, or you have an embedded system, or you're in, anywhere. Those top 10 are a standard that people need to be aware of. And so with that comes a bunch of cheat sheets. So these are short summaries of specific vulnerabilities and how to protect against them. So once you have that foundation, you can move on to actually using some of the vulnerability applications and the testing that you can then start using to test your applications and also to test your knowledge. So Security Shepherd is an application for understanding vulnerable web apps. It gives you some lessons and helps you learn more about that. There's also WebGoat and OWASP Bricks. So again, lots of content there that you can use to improve your security knowledge. So as I mentioned, the OWASP Top 10 Web Application Security Risk is a standard awareness document for developers and for web application security. So it's specifically targeted for web application, and there's even top 10s now in OWASP for other areas like mobile security. And it represents a broad consensus about the most critical security risks to web applications. It talks about, so every couple of years they publish it, and actually some of these vulnerabilities move around on the list because, every year attackers, they change their tactics. So for example, cross-site scripting, which is number 7 on the list in 2017, used to be much higher on the list, has fallen down because some of these other things have become more prevalent in attacks. So the top 10 includes things like injection, broken authentication, sensitive data exposure, XML external entities, and broken access control. We're going to talk about those in this presentation. But I do encourage you to take a look at the other ones as well. There's lots of useful information in those. And OWASP is a great framework for looking at, these are the top issues that they see in the field, in the wild, in the real world, that are being exploited. But you can also dig deeper on those and find out, well, what else is there? So let's dive in with the first one, which is injection. So many of you may have heard of injection, I don't know, but the injection is one of the top flaws that can be exploited and can cause a lot of damage, because it allows an exploiter to extract data directly out of an application. So there's different types of injection. So SQL injection, SQL is a structured query language, which is a language used for database queries. NoSQL, also very similar. It's NoSQL databases. OS is operating systems. There's a way to inject flaws into operating system calls. And also LDAP, which is another database technology. So all sorts of different types of injections. It occurs when untrusted data is sent into an interpreter, and that interpreter, it tricks the interpreter into executing that command on the application, and then it accesses data without authorization. So let's take a look at how an attacker exploits this. So first scenario is you have a statement like this in your code, this is a SQL statement. So select all records from accounts where customer ID equals, and then you grab the parameter, which is the ID parameter, and you put that in the select statement. So this is a vulnerability right here in the code. And what an attacker can do is they can modify the ID parameter in the browser. So if the browser is transmitting that ID parameter, they can modify it so it's right in the URL, and they could put this string, for example, just a quote, or 1 equals 1. And what that does is it changes the SQL, it changes the meaning of the SQL to return all records from the database instead of just one record, because the 1 equals 1 is true. So this is selecting where customer ID equals nothing or true. So basically it always defaults to true, and then it returns every record in the database. Right? So this is what the select statement would look like. And this is a dangerous attack because it actually can grab all records out of that database that the user's not authorized to see. But there's even more dangerous attacks to delete data or even invoke stored procedures. So let's take another scenario. For example, you have a piece of code that gets a user ID, and it then uses that user ID to select data from a database. So this is your code. There's a vulnerability here because, again, it's taking this request string from the HTTP request, and it's putting it directly into the select statement. So suppose the user gives the following input. They put in a user ID, put a semicolon, and then put drop table suppliers. So what happens in this is the interpreter will actually run the select statement and then run the subsequent statement, drop tables, and that that destroys the data in the table, and you lose all that data. So changes the meaning. Oops, that should say it deletes the data in the database. So how do we protect against this? So this is where the OWASP comes in play, so the suggestions are you have to put some input validation. So very important to validate your inputs on any user input. So for example, in that case, if a user ID is is numeric, you should validate your inputs that there's no non-numeric content in that user ID. That's a very simple way to do it. You may also put a bounds check as well on that data to say it can only be between these two numbers, right? Another really important way to protect against SQL injection is with something called parameterized queries. So I put an example of that here. So there's a way to put a parameter into a SQL statement like this, @0, And then when you use this parameterized statement, it will take that user text and will insert it into that parameter, and it won't execute the content of the parameter. So that's the protection, is that the danger with the SQL injection is that it interprets the content of that string that you sent it, which has the 1 = 1. So in this case, it won't interpret it. It will only treat it as a parameter. So that's one way to protect. Also, stored procedures can protect with a similar way, because stored procedures in the database are basically a function call with parameters. And so those parameters have to be typed. So typing a parameter means you define what are valid values of that parameter, and then only pass those valid values. Also, whitelisting input validation. So as a kind of like where I said, if you take you have a numeric input and you only allow the types that are allowed, only allow the numbers that are valid for that type. Or for example, maybe you only have, maybe it's a menu selection and you have like 5 options. Well, you check that it's only one of those 5 options and it can't be any other option. So the least desirable way is to escape the user input. So what that means is you take any special character like a semicolon, you either strip it out or you put a backslash in front of it so it can't be interpreted as a actual semicolon for execution. So that's some examples of how to protect against SQL injection. And as I mentioned, this is SQL injection, but it can happen anywhere where you have code that gets executed, where you're taking a string and then you're putting that string into some code that then executes. Maybe it's an exec on an operating system to open a file. Well, again, that could be, if it's done through an interpreter and not through a call to file open, if it's done through an interpreter, then it could actually execute code. So let's look at the next one. So the next one is broken authentication. So authentication is a fundamental feature of almost every application. There's got to be some way to authenticate a user. So that's to identify the user and to say that that user is a valid user to use this application. So there's broken authentication refers to 2 weakness areas. One is session management and the other is credential management. So the credentials are the login and the password, for example. The session is established as the user connects, and then they want to maintain that connection after they authenticate. So both are classified as broken authentication because attackers can use these to masquerade as another user and can use the stolen login credentials. So in recent years, broken authentication attacks have accounted for many of the worst data breaches because they allow an attacker to extract credentials. And often what happens is people use the same password on different servers or different services. And so if an attacker has stolen credentials from one service, they can mount something called a credential stuffing attack, where they use those credentials against other services to see if they can get into those services. So we're going to talk through that example attack scenario. So for example, credential stuffing is using a list of known passwords, whether it's passwords that an attacker has actually exploited or that they purchased on the dark web. So again, when an attacker grabs these credentials, they go and sell them on the dark web, and other attackers can buy those lists of credentials and then use them to go and attack a victim site using a botnet, for example. So they take those compromised credentials, they use a botnet that then is a distributed set of servers that go and take those credentials and go and try to insert them into another victim site, right? So if that site doesn't protect against this type of attack, where then it can be used to gain more information. So for example, it can be used as an oracle to determine if the credential is valid on that site. And so this type of attack typically does repeated requests to a victim site, and it tries to use a lot of different password combinations. But those passwords are passwords that have a very high chance of success because they came from attack. Another type of attack is a brute force attack, where they take every type of input and try to throw it at a victim site. So there's some standard ways to protect against that. I'll talk about those in a second. Another type of attack scenario is something called session hijacking. So a session hijacking occurs if the application session timeouts are not set up properly and the sessions are not encrypted. So if an attacker is snooping on, for example, a public Wi-Fi network, let's say they're at a coffee shop, and the coffee shop has a Wi-Fi that's not encrypted, they could actually steal some of the session information. So if you're on a public Wi-Fi, anybody can actually listen to the traffic that's going by on that public Wi-Fi. If your application doesn't use encryption, then or you're not using something like a VPN, then anybody can see the traffic that's going by on that Wi-Fi network. And if, for example, the application sends the password in the clear, like this example, they can actually grab that password and then use it on the server. Now, let's say that the password is using TLS, but if the session identifier comes back and that's not encrypted, then they can take the session and they can reuse the session and hijack the session. They can also steal that session if the session doesn't time out. Maybe you've long gone. They can reuse that session ID or the session cookie. They can actually impersonate you on that server. So that's a very dangerous attack, and it can be done in a number of ways. Again, if there's certain parts of the transaction that aren't encrypted, then the attacker can inject themselves into that part of the transaction. So how to protect against this? So authentication is a very large area of knowledge. So I would say there's a lot to learn on this stuff. I've just put a few things down here that you can think about. For example, implementing password strength controls. This is about the complexity, right? Adding, letters, digits, capitals, and different types of symbols. All of that increases the complexity of the password, making it harder for a brute force attack. And then the length of the password as well. The longer you get, the harder it is, and it exponentially rises in the number of attempts to break a password like that. Also, secure password recovery is really important. So some attacks will look at, okay, the forgot password functionality and exploit that. And it's tricky to get that right, because the forgot my password functionality happens when you're not really authenticated yet. So you have to consider that in your solution. It's very important to store passwords securely and use very safe functions to compare those password hashes, because it can get into the cryptography of it. We'll get into that a bit later, but using the correct cryptography for passwords is important, because certain hashes are very fast, so attackers can use them and can break passwords much quicker. Also, make sure you're always transmitting things over TLS. So whether it's login screens, your passwords, your session cookies, those all have to be transmitted over TLS. And you want to require re-authentication for sensitive features. So for example, you could do something, for example, let's say you're in your bank, you've logged in, you're authenticated on the bank, and now you want to initiate a transfer. Well, you could actually prompt for a re-authentication there. That's a useful way to strengthen the security, so that if somebody has a session cookie, for example, and they've logged into your bank, they can't do the transfer, because now that's going to prompt them for a password. So that's a good example of how to secure things. Also consider strong transaction authentication, and protecting. Another very useful way to protect against automated attacks is using multi-factor authentication. So this is where, when you log in or whether you're trying to do something, it actually sends you a message to your phone, or it requires a secure token where you enter the code on the token. And so it's a second factor in addition to the password that actually thwarts a lot of attacks. And so many of the biggest and many applications now are using multi-factor as a way to secure, and it's a very effective way to secure applications. Also, on the session management side, you want to look at things like controlling the session length with a timeout, making sure that timeout is reasonable, so it doesn't make your users really frustrated because obviously if you're logged in and it logs you out right away, that could frustrate your users. But it is important to have some timeout. Also rotating the session IDs. So for example, if you're using session IDs that are generated, an attacker might recognize how they're generated and be able to predict a session ID and then use that session ID. So you have to have session IDs that rotate. Also, not putting the session IDs in the URL. You could use something like session cookies, or JSON web tokens is a very useful topic. So I put a link there for JSON web tokens because that's a very recent development that is being used now for session IDs and for authentication, and specifically around things like OpenID and OAuth authentication. Also, you can understand your built-in session management frameworks. That's a very important piece too, because nobody should be writing this stuff from scratch unless you're developing frameworks. But the frameworks are there to help you do the session management, to do the authentication. And so understanding those frameworks is really important, and understanding the nuances to how to use them in a secure way. And like I said, always use TLS for your entire web session. So hopefully that's helpful. There's lots to know about authentication. There's some links below to explore a bit more about that. So the next topic is sensitive data exposure. So on this topic, this is about how to protect data like passwords, credit card numbers, health records, personal information. All of those things require extra protection. And your users expect you to be protecting them. Those are the things that when they get exploited and breached, they're in the news, and it's very damaging for a company. So this is number 3 on the top 10. This is a very, very critical piece around sensitive data. The first 2, SQL injection and the authentication, are the top 2, but sensitive data is up there. And you'll find as I'm going through this that a lot of the issues in here are combinations of these vulnerabilities. So what it says here is, rather than directly exploiting the cryptography, which is very, very hard. Trying to break a cryptography algorithm is very hard. Attackers can just steal the data from the web application in a number of ways. They just look for things that aren't encrypted, or they look for holes in the way that things are stored or how keys are used. So it's very important that you use the keys and the encryption in a very safe way. So let's take a look at a potential attack scenario. So this is a technique known as Google hacking. So you can take a look at the link there for Google hacking. But Google hacking is a technique where an attacker searches for certain strings on Google, and that will allow them to expose sites that have vulnerabilities. So for example, they're looking for the string admin password, and they're looking for it in text, log, and config files. And I ran this yesterday, and I had a bunch of results showed up with sites that have admin passwords that are in the clear. So for example, in these cases, now some of these cases may be just test servers or something, but I mean this should never be the case that you have an admin password that's indexed by Google. And this is actually a really good technique for you to test your site too. I know we've done this at my previous job, where we would do some Google hacks on our domains and look for where are our domains showing up on Google. And you go through a few of the pages and find out, okay, are these legitimate things or are these data exposure? And so it's a useful scenario to be aware of. The attacker can then use those passwords to gain access to the resources on those websites. Another scenario is where, for example, an application may be encrypting credit card numbers. They're doing the right thing to encrypt the credit card numbers in the database, and it's encrypted at rest. However, the database automatically decrypts them when you retrieve. So what that means is that if there's a SQL injection flaw, it'll decrypt after you run the SQL transaction, it decrypts it, and so all of this stuff comes over in the clear text. So that's a case where it's, there's a partial measure in place to secure the data, but because it's not encrypting it on the way out, it leaves that data exposed to being exploited. So best practices on data exposure. First of all is really classifying your sensitive data. Make sure that you understand what data is sensitive, which data is private information, and don't store it if you don't need it. So this has become really important in, for example, there's a policy called the GDPR in Europe where they require that you make sure that you've classified your sensitive data and you're not storing data that you don't need to store. Discard that data as soon as possible. So you may be holding, for example, information to do a transaction like a credit card information, and if the user doesn't say, I want you to save this, you can just destroy that data securely and never store it in your system, and then it doesn't become an issue. You can also encrypt the data at rest. That's very important. Never store it in plain text. A lot of breaches happen because things are stored in plain text, they're not encrypted, and that attacker comes along. Maybe they've breached the initial defense, but then they look around on the network and find data that's in plain text stored on the network. Also important to use strong up-to-date encryption algorithms. There are some encryption algorithms now that are no longer secure, and so you shouldn't be using them. AES is a good one, but other things like DES are not secure. So consider using a peer-reviewed library like Google Tink. So Google Tink is a library that has well-known encryption algorithms, and it has a nice interface to be easier to use for developers. Also, manage your encryption keys securely. So this is a very tricky thing. It's kind of a chicken and egg problem where if you want to encrypt something, you need to use a key to encrypt it. Well, how do you store the key? The key, you don't want to put that key in your code because, your source code may get, if that gets exposed, then people have access to the key. And sometimes that happens if people are writing code and it's open sourced. People go looking through the open source and find the encryption keys that are embedded in the code. So that's not a good practice. You want to store those keys in a secret store or some kind of a secret vault. So there's things available that allow you to do that. Things like Keywhiz, HashiCorp Vault, and Amazon KMS. And those vaults allow you to store keys securely, and they keep them out of, you don't want to store the key on disk in plain text. You don't want to store it in the code. You want to store it in something that's extremely secure. Also, you want to encrypt data in transit with protocols like TLS, and make sure that you're using some of the advanced features like perfect forward secrecy and strict transport security, which will protect even more on TLS. So number 4 is external entities in XML. So XML external entity attack is kind of like a SQL attack, right? It attacks an application that parses XML inputs, and it occurs when somebody uses an external entity tag in XML, which allows it to execute some code on the XML, on the machine that the XML interpreter is running on. And then, so again, this can lead to disclosure of confidential data, can lead to denial of service, server-side request forgery. It could even allow an attacker to do port scanning internally of machines on the network. So let's take a look at how this works. So let's say an attacker discovers a gaming website that allows a user to upload game configurations in XML format. So the attacker uploads the following to the XML server. So as you can see, this XML document has an external entity here. And what it does is it accesses this system file, which is the etc password file on the server. And so what that does is it results in the server displaying the contents of that password file to the attacker, which he can then use those passwords to go and access servers over the web. So that's a very dangerous attack. Now, sometimes these external entities are, the XML may parse it and it doesn't display it to the user, but the user can actually try doing different things with that. Maybe it's not going to expose data, but maybe it's still executing that. And so another attack, for example, is this. This attack is a server-side request forgery. So an attacker attacks, again, a 3D printing website, for example, allows users to upload CAD drawings in XML format. The attacker uploads the following XML into the server, again, using the entity tab in XML. And in this case, they put a URL in here, and that causes the server to make a request to that URL. Now it's executing that request on the server as the server's user. So if you're running a service account, the web server is actually making the request out. So it's not the user now that's making that request, it's making that request. And so this type of attack can be used to gain access to other resources on the private network of that server. This is called server-side request forgery because the server is now making the request, not the user. So the server that's hosting the website makes the request to the named website, and that can be used again to access privileged information. Maybe it's making a request for data from another server, or it may be using that to look at and look for other servers on the network and understand what's in the private network. So it can be used for a number of things, and so this is a very dangerous attack as well. So how to protect against external entities? One simple way is try not to use XML, use simpler formats. So JSON, for example, it's just the data format, it doesn't have any code execution. Or make sure you've patched and upgraded all of your XML processors and libraries so that they don't have this flaw. Disable the external entity and the DTD processing, and verify that XML functionality validates the incoming XML, right? So that's another way to protect against this one. So let's take a look at number 5, broken access control. So authentication, access control are both kind of parts of the same thing, which is getting access to a server and then giving access control to do certain functions. So the point of access control is to enforce that a user can only act within their permissions and not outside of their permissions. And so typically, the failure of this can lead to unauthorized disinformation disclosure. It can result in the destruction of data. It can allow users to, for example, authorize a payment or grant permissions to another user. So those sorts of things if the access control is broken. So let's take a look at an example of this. So in this case, the attacker observes the following request made by an application when loading their bank dashboard. So they look at the URL and they see that it actually has an account ID. And so what they do is they take the server code. The server code takes that account ID again, and it uses a parameter to set in a statement and executes that statement. So it's kind of like the SQL injection, but in this case, instead of doing a SQL injection, the attacker just changes the ID from 4462 to 4463 to see, okay, it's not an injection attack, it's actually just saying, can I access a different account than my own account? And so if the access control is broken, it gives the attacker the results of the other account. So this can happen anywhere where you're exposing the account ID as an input to your server, and allowing a user to change that without making sure that the access control is set for that specific user. So again, it exposes data. It potentially, again, if that user can make changes to that data, that's even more dangerous. So that's one attack scenario. Another attack scenario is where, for example, an attacker reviews the HTML code from the website and finds a comment in that HTML code that says there's another path that they can use if they're for a support team. So sometimes a given server has a path for users and then has another path for support engineers who need to test things or need to help a user. And that support path generally requires a higher level of privilege. Now, if that, again, the hacker sees that, number one, that's a type of involuntary disclosure that you're giving the hacker information about how to exploit your system, and they're going to try exploiting it. So they're going to craft a special request that's going to try to hit that path. So for example, they generate a request that hits that path and see, does it grant them access? Even though they're not a support user, they're a regular user. And if it grants them access, they're in. Now they have access to customer information. So that's another type of attack scenario where the access control is broken and not limiting the user to just the permissions that they have. So how do we protect against this? One important thing now is making sure that it's enforced on the server side. So often there's a lot of code now that's being pushed into the client side, whether it's in a mobile app or whether it's in the browser. All of that application code is subject to being snooped and being read by an attacker, and they have a lot of control over that. And so you want to ensure that you're doing enforcement on the server side, and that you don't trust the inputs that are coming in from the client side. You have to always sanitize those inputs and assume that somebody could be intercepting that input and changing it as it's coming through. So don't trust that your client side is always acting in a controlled way. Always test it and make sure that, okay, this is the way, this is the access that is supposed to be there. Also, with the exception of public resources, you want to deny access by default. So if you've used cloud services like Amazon, you'll note that everything is disabled by default, and you have to go and create an access permission, enable access permission to be able to access certain areas. You also want to implement access control once and reuse that throughout the application. So very much like authentication and session management, you want to have one consistent way of implementing all of that, typically using a framework, and use that throughout the application, and always check your authentication, your session, and your access control as any requests and functions are coming through. Also, one of the things you want to do is disable any kind of web service directory listing. This is typically on the web server. You want to make sure you're setting that configuration in a strict way that will not allow a user to list all the contents of your directories, because they can then find other paths, they can find other data that they can try to exfiltrate. You want to also log access control requests and alert administrators if there's an excessive number of requests coming from a web server. You want to rate limit as well. So rate limiting an API protects against automated attacks, so that after so many attempts, it says, okay, I'm gonna lock it down and not allow any more attempts, and that just makes the attacker's task harder. And also make sure you're testing this stuff in your unit tests and integration tests. You want to test the access control in your test. Same with authentication, session management, all of those other things. You want to be testing it all the time. So that covers the top 5. As I mentioned, there's a lot more to go into on the next 5, and there's other things as well. As you learn through this, you'll find that there's a lot of pointers within the OWASP to other content that's interesting, other types of vulnerabilities, and just be curious. There's all sorts of, when you see a vulnerability or you see a breach, for example, try to find out what was at the root of that breach, and then go and research. Okay, what did they do? Clickjacking, or for example, bit mining, things like that. So one thing that's really helpful as well that every developer should know is that there's tools. The tools are there to help you, and there's lots of really great application testing tools. There's 2 classes of tools that I'm going to talk about. One is the static application testing tools, and then there's dynamic application testing tools. The difference is static tools tests the source code, and it looks for vulnerabilities in your source code. It's a really quick and easy way to find vulnerabilities. And essentially it says, it's codified the idea of this is what a vulnerability looks like in code. and it looks for those, those types of vulnerabilities in your code, and then it gives you a list of them. And so I've listed a few down here. There's lots of them. Some of them are free, some are commercial, so you can use those in your code. And it's easy enough to take one of those and put them into your build pipeline, so it's an automated process. And if you start early, it's the best to always do that at the early stages of your development, because what happens often if you do it later is that you end up with lots of things to fix. So if you're keeping up with it early on and running it all the time, you'll have a very clean code, and it will be very secure from the beginning. And it's hard to do later. And often, the reason why those big jumps in the vulnerabilities is often because companies take existing code that they've had for years and years, and they run checking on it, and they find lots of vulnerabilities. And then they look at what are the high vulnerabilities, and they publish those. And so that's one thing. The dynamic checking runs during the runtime of the application. So it analyzes the running application to find security vulnerabilities. This can also be automated during your pipeline. So for example, in our pipeline, we were running some of these checks after we built a VM. We would run the checks against the VM, and it looks for vulnerabilities that are in the running code. So things like XSS, which is the cross-site scripting, or insecure configurations, it can detect those types of things in the running code, and it can alert you. Some of the OWASP, for example, OWASP Z-Attack Proxy, which is down at the bottom there, that's an OWASP project that looks for and tries to attack an application and can alert you to certain vulnerabilities in that application. So use the tools, they're there to help you. Also, I want to just mention there's some next generation tools. One that just rolled out this past week, exciting, was GitHub rolled out a new code scanning security feature to all of its users. So now if you're using GitHub to store your source code, you can use that scanning feature now to scan for security flaws in your code. So that's a really helpful thing. And then there's Amazon has something called Code Guru, which is exciting, which is using machine learning to look for vulnerabilities in code, and also looks for performance issues in your code, and can advise you on critical issues that are hard to find. So use the tools that are there, and they can really help you find things. And it's also a great learning tool as well, because if you find a vulnerability in your code, you have to go and understand, why is it vulnerable? What do I need to do to fix this? So really, in conclusion, I want to encourage you to keep learning. I mean, this is a wonderful forum. The Moat Academy and the Secure Coding Bootcamp is a great way to continue learning about secure coding. Take a look at some of the links in the references in this slide deck. Also, experiment with the OWASP tools. There's lots of great tools out there, and you can learn a lot just by using those tools and trying to exploit some of the applications. So OWASP has some applications that you can use you can try to exploit. Don't go doing this on any public websites or any commercial applications, because that would, that wouldn't be right, and that would contradict their terms of use. But there are tools that are applications that you can test your skills on in OWASP. And let security awareness be your superpower. Try to become aware, and that can really be so beneficial for you in your career. And your managers, your peers, everybody's going to up their level if they're much more aware about security. And overall, really stay safe and stay protected and stay secure. So that's all I have to say. Here's a list of references, and I will open it up for questions. So Abiola, is there a certain way you want to take questions?
Okay. Thank you very much, Moataz. So this is the time for question. If you have any question, please send it in as chat, or you raise your hand so that you can be unmuted. Okay. Okay. All right. So question for Raymond. Your question has been taken.
Okay, yeah, I will post the slides, and I will send a link out to you, Abiola, and then you can share out the slides. So definitely you can have a look at the slides.
Okay. Thank you. Any other question? Okay. Thank you very much once again for honoring our invitation, Moataz. It was indeed a great session. So we really appreciate you. And we believe that everybody has learned what they need to know as software developers. At Moat Consulting, our goal is to raise developers that will go to different companies and implement security and quality. So, and at Moat Academy, we have been doing that. So the Secure Coding Bootcamp is an advanced training that is to enhance the skills and knowledge of developers so that they can also keep writing secure codes. So the bootcamp that will be starting October 17th, the participants, we have selected some applicants. So if you have been selected already, this is a preparatory ground. It's just a tip of the iceberg, and we encourage you to keep looking forward to when we'll start the major program. And if you have not applied, I encourage you to go and apply on our website, securecoding.moatacademy.com. Thank you all once again. Thank you.
Okay, thank you. Okay, bye everyone.
All right, bye.
Bye.